Hello.
Hi, Eduardo. Hi.
Hello.
You okay? All right.
You look stressed, Lucas.
Sorry?
You look stressed out.
No, I'm not stressed out at all. No, I'm all right. It's going to be a long night today.
Because?
I still have to work on my website. Like,
Oh, don't
website
worry.
is a big word.
There is plenty of time left.
Yeah. But the thing is, like, I'm most productive at nights. So, yeah.
Yeah, me too, by the way. Don't worry. Me too.
Yeah, I know. So, yeah. I have to keep going. But I guess I'm on the right track at least. It's starting to look like an actual website, if that makes sense.
Great to hear. Yeah. Great to know that.
It's ugly, but at least it works, right?
So, okay, I will wait just 1 minute because just in case somebody else is connected, but I don't care if we are only one or two. We're going to run the normal hour, just like yesterday. But in case somebody connected, I will wait 1 more minute. Hello, Sif.
Hello, guys.
Hello.
Hi.
Getting super dark.
Yeah.
Like my soul. I dreamed about Flexbox last night. I swear, I'm not even joking.
Oh my God.
that is what I am sort of obsessed with at the moment. But I figured out grids today, so
Oh yeah, I read. I'm sorry, I don't know why I didn't see your message because I actually was I wasn't on the computer, but I was on the phone checking if somebody needed help. And when I saw your message, it was almost 40 minutes ago, later. And there is a nice web page that actually allows you to set up the grid template areas quite easily. Let me show you right now. Just 1 second.
oh, that'll be cool. Because I had some weird issues with like grids within grids, but that was just I just
if you go
tags.
grids into grids, maybe we have something that solve there.
Well, just one nest. So I have like a grid layout just to have like my navbar at the top, foots at the bottom, and a body. And there is one situation where I'm creating a grid of the body or the main section as well. So it's not like nested. It's
Okay.
One in one. But I messed up my tags somewhere and then almost threw my MacBook out the window from frustration. But
don't worry, that happens. That's the reason that we spent so much time actually writing HTML, because I know that HTML, I can just send you a 5-minute tutorial, but it's so important to stress out, check out your tags if you're actually closing correctly, because that's the key in React. Once we re-enter React and you start modelizing stuff, it's supposed to be easier, so you don't need to care about the tags, but that's wrong. Because people get too much comfortable with writing the components in React to the point that when they render the project and start assembling the project and you need to debug the stuff and you open there is a special tools in React to visualize the components. At that particular point, you will see that all the stuff that React was making your life easier will pay you back as soon as you see, okay, if you write bad components because you have a bad habit of writing bad HTML, when your project grows, it will pay you back. It will hunt you back, and it will say, that's why you need to write good HTML code, because in small projects in React, you can get by. You can write shitty HTML, and the components will mask out the problems because you can just create one component for the heading and reutilize across multiple pages. Your project grows, and now you need to debug. That's when it pays you back. It will hand you back if you actually didn't wrote nice HTML inside the components. So that's why we take the time. Hey,
Makes sense.
I see a nice amount of people. So, okay, let's get started because we don't know how much everyone is going to connect. So let's go by the very basics. I will close this one. Close this one. Let's go with TypeScript. Okay, what is TypeScript? Now that you started the SDA learning Java, and many of you already had some experience in coding. And if we talk about coding, we know that the most famous standard is object-oriented programming. So we know about classes, strong typing, inheritance, and so on and so forth. I will not repeat the Program Foundations course. But you learn a strong basics or strong foundations, that's the name, to build a good code. You did that in the develop project. Once you mix up the concepts of class diagrams to have a nice overview of your project, you make a nice project a couple of weeks ago. Then you switch to JavaScript, and all the concepts of object-oriented programming went to the trash can because JavaScript is a disaster. It doesn't have classes. Right now, a couple of years ago, they implemented a system of classes, but it's a fucking joke, to be honest. It's like making a 5-year-old. Yeah, it's like making a 5-year-old play against Real Madrid. They're playing soccer, but they are not in even the same league at all. They will take years so they can catch up. So yeah, JavaScript classes are so bad to the point that even experienced developers just skip it. So the product is so bad that nobody's using it. Well, long story short, the inventor of C#, a competitor of Java, and a nice language, by the way, created by Microsoft, said, you know what? JavaScript is ubiquitous. Is everywhere. Is in the browser. Is in the servers with Node. Java's everywhere. But we really hate typing in Java. But people can create precompilers, and this is the word that we were speaking on the morning. What is a precompiler? Well, now that you create classes and create a project to create a to-do list, you can now create a to-do list item. Somebody that is super smart said, hey, what if I use a programming language to create another language? And basically that's a precompiler. So somebody took the time to write a JavaScript code to create a new language that is better than JavaScript and compiles back to JavaScript. It's quite a messy, but let's go with the flow. You know that JavaScript is everywhere, so that's super good about JavaScript, but we hate that it's insecure, doesn't have strong typing. The classes are so bad that people doesn't use it at all. We want to use that features. So somebody wrote a language on top of JavaScript, so you can use those features. And once you finish your project, you can compile back and it will become a standard JavaScript. So that's basically TypeScript. What are the benefits? Well, strong typing allows you to check a lot of cut a lot of mistakes even before you publish your project. So you will start writing code more confident. You are less afraid to add more features because you know that you have a compiler that has your back. It will catch silly mistakes. It's nothing more annoying, just as Hermanos was telling a couple of minutes ago, having a problem because you don't have a closing tag. Nothing is more annoying having problems in JavaScript because you're passing elements you're passing functions, and then you're passing functions over functions, and the functions has arguments, and at one point you know that you can pass anything, and JavaScript will never throw an error. Hey, for example, you can create a function that for example calculates the tips in a restaurant, so you get the entire amount of how to pay and also the tips. And you can pass, in JavaScript, you can just pass an array or pass a name instead of 2 person numbers, and JavaScript will never complain. So at one point you will start writing code that you don't know what it actually makes sense or not. In TypeScript, in Java, or in any language that actually has a strong typing, it will code these kind of errors. Hey, you're trying to pass names or arrays inside a function that only expects 2 numbers, one for the amounts of dishes consumed, and one just for the tips if you want to tip the waiter, or what you just pass a 0. That's it. So this is the benefits of TypeScript. Let's start seeing that benefits on a small example. I have a couple of snippets already built, but we're going to create a new project from scratch. So I will delete this one. I have one example that is incomplete. I will finish it today and then pass it to you or do a Git repository later. But let's go with as much code that we can see today. I will close this one. I will create a new project. Close this one. I will create a TS live. This is a new project. I will close Visual Studio Code. This is a nice tip, by the way. If you drag and drop an empty folder inside Visual Studio Code, it will open your project right away. So,
magic.
Yeah, that's a nice tip. So let's start with TypeScript. How do we start? First, we need to have npm installed. And the first video that I recommend you was to install TypeScript. The command to install TypeScript is npm install TypeScript G for global, so it's available on the entire computer. I already have installed it, so I will skip this one. But once you have installed TypeScript in your computer, you can check if it is working by pressing TSC. I don't want that you memorize this command, because if you try to memorize it, in a couple of days later, you will try to write something like this and will say the command doesn't work. So remember, these are the initials for TypeScript compile. So that's TSC. So remember the TSC. And I can check if I have the version installed by pressing TypeScript compiler space -v for version. And let's create a small project in this folder. How do I do it? TypeScript compile space --init. And the terminal says you have created a successful TSC config file. Where the hell is this file? And this file has a lot of options. Basically, this JSON file will tell the TypeScript compile, how do you want to compile this code back to normal JavaScript? There is a lot of options. This is a quick course, so we're gonna see that in details. We're gonna go to the most popular ones. This one, target, will tell you which version of JavaScript you want to use. The ES6 3 is the oldest one. Don't care about that one. The ES5 is also old. The one that everybody is super happy about is the 6th version. So we can compile to that one, ES6. I will change this one to the modern version. So you will have the nice modern features like a map, filter, and so on and so forth. And I will tell the machine where do I want to put my files. Remember, we have created a project, but we don't have any organization. When we created a Java project, Java created a nice folder source and so on and so forth. So we need to recreate the same functionality. I will tell my output of the directory will be, for example, I will create 2 folders. One for my TypeScript code, the real code that I will modify, and then one just for the compile code. And I don't need to do the air quotes. It's actually compile code that I will call JavaScript. So let's create these 2 folders. Right click, new folder. What happened? New folder. One called TS for my source files, and one folder called GS for my compile files. Perfect. And now I will tell the machine, each time I create a new file, I want that you compile it automatically. So I don't need to save or press render or press play or anything. Just write code, save it, and it will compile for you. So how do I do it? TypeScript compiler space -- watch. And it throws an error. There is no files to compile. Oh, thank you. So hey, you can see the first advantage of TypeScript. Now we have a terminal window with a compiler telling us we have some kinds of errors. So let's create a dummy file. So for example, example1 example 1.ts. Perfect. And it just created a file for us. Of course, the file is totally empty, but you can see something called use strict. That means that we're going to use a couple of features in JavaScript to enforce nice coding. So, for example, avoid using bars inside of functions, avoid using double equals when everybody should use triple equals in JavaScript just to avoid any kind of mistakes, and so on and so forth. So even if we haven't write any code at all, TypeScript is trying to force you to have nice practices. So that's super good. So let's create a small example. Const, we're gonna create classes later. We are gonna start simple before we go build more complex projects. So constant, for example, name, and I can use a new feature called 2 colons, and I will say a string, something that JavaScript doesn't have at all, and we'll say Eduardo. Perfect. Name is a reserved name, so I cannot use that one. Already the TypeScript compiler is helping me, telling me that I cannot use that name, so I will create my name. My name, perfect. No errors. Now we know that the project is working. I will create a quick function just to say hello. Super simple, basic stuff. So for example, function greet, in the standard practice, a name, and the name will be type string. I will pass age as well, and the age will be string as well. And I will just do a simple console log. I use backticks, so I can do a quick string concatenation. So hello, name, your age is an age. And I don't want the age to be a string. I want it to be a number. So nice. So far, so good. And I will call this function, greet. I don't have a variable name, so I will create it on the fly. I will pass my name. And I get an error. I get an error here, and I get an error here. And I can read in the terminal, in my console, that where the argument age was not provided. That means that, hey, you're forgetting about something. Normal JavaScript will allow to do that, and it will fail on the browser. And then you will figure out over there that you actually had a problem. So okay, I will pass the age, no problems, 34, for example. And the compiler is still making throwing some errors. So it's telling me that I cannot pass a string because it was expecting a type number. Oh, perfect. So I will pass a number. There you go. Now found 0 errors. I know that this code, at least from the syntaxis point of view, is working. And I can check it out, my project, this one. And you can see that it's quite similar. Let me just add a little bit of spacing so it's easier to read. My name, and if I pass the mouse over there, there is no information of what kind of data is this one, because JavaScript doesn't know about strong typing. In this one, the function greet, it has no information of what type of data is this one or this one. So this is why JavaScript can be so dangerous and people hate it, because you can pass anything, and JavaScript doesn't care at all. It will throw an error, of course, but it will not tell you that you're making mistakes while you're coding. So that's kind of shitty, to be honest, from JavaScript part. So with just this small example, you can see how good can be TypeScript to help you code. So even the most basic projects can benefit from TypeScript. But TypeScript was designed to handle classes. So this small project will actually not scale at all. You're thinking about using classes, you want to make a complex project. So let's build something quickly using classes. Before we start coding, I want to visualize what we want to intend to do. We're going to replicate one of the first BlueJ examples. So I will go to Whimsical. I will create web development. I will create a small quick diagram. I will not even call this a class diagram because this is super basic. I want to create an example of a classroom. A classroom had a name and a list of students and The student has a name, it has a couple of properties and credits. So we're gonna create a project where we'll create a school project. I will paint it in black. And this one will have a class called a classroom. Perfect. And we're gonna create also a student class. So we're gonna have 3 files, one for the school, one for the classroom, one for the students. And now let's do something similar to a class diagram super quickly. Let me delete these ones. So for example, in the classroom, I will have the name of the course name, course name. It will be a property because we're not talking about variables anymore. We're talking about object-oriented programming. So instead of using the word variable, we are going to use the professional name property. This one will be a purple one, and the type will be a string, something that we don't have in JavaScript. Now we can start speaking about data types. We're going to have another property called students, plural on purpose. I will paint this as black, so we know there's a property, and we're gonna create an array of students. So how do I tell that? I will literally say student because it's a class and it's an array. So this is how I denote it. And I want to just get a list of students. I will create a method called get students, plural, and the type return will be a student as well. So let's create this in my small diagram in the spreadsheets. Let's create the student class, student. The student can have a lot of properties, but because we want just to make a small example of interacting between these two, we are gonna just make a quick name, a quick property name, type, string, another property, credits. I would say number, type number, and a method to create to add credits. So literally set credits and type number. And because now we are talking about classes, we also have the concept of constructors. So look that I don't have a I will add a method to, of course we are talking about classes. We are gonna add a method to get name for the student, and method get credits. So it's also number, and I will organize this one. First, my getters. I will put my getter here and my getter credit here, and set credit. Notice that I cannot. I haven't created a set name on purpose because we're going to use a constructor to define the name. And once we create the student name, I don't want to change the name at all. We're talking about a little bit of about object-oriented programming. So I want to make my class secure by only allowing to modify the credits. But once the name is created, it will not be able to be modified. So let's create these classes. Let's go to Visual Studio Code. I will create a new class, a new file, the classroom, classroom.ps. And now we have a classroom. And let's create the same data that we were having here. So to create a property inside a class in a TypeScript class, you cannot use constant. You will throw an error. You need to use a private. And private will be, for example, the course name. Or actually, I can just name because we know that if we are inside the classroom, we know that name is the name of the classroom itself. So a string, perfect, and a private students, plural. This will be an array of students. Yeah, there you go. A student, and it's an array. Perfect. Now, when I want to create a constructor, in the constructor, I will say name is a type string, and students is a type of an array of students. Student array. Perfect. And I will assign the values.
Sorry about it.
Yeah, ask me a question. Yeah.
Great. I think there might be a pause later on. So line number 3, you have a typo in a word student. Probably that's going to haunt us, come back to haunt us later on.
Oh, yes, you're right. And thank you for that one. A student.
Yeah, sorry for being picky, but I guess.
No.
No,
You're not being picky. You are being cautious, and that's excellent. Thank you so much. So, but name will be sorry. This to access the private private property. This dot underscore, and look. Now that we are using classes, TypeScript is becoming even more intelligent and is helping us even further. And you can even see, if you can see a blue icon is a property. If you see a purple one, I think it's a method. So in this case, this name equal name, perfect, and this student equal students, perfect. But you can see the red line. I cannot find the name student. Where the hell is that? Because we never created the class. So let's create another class called student singular, because this one we intended to be an array of a single type of student. PS class student, and I will pass private name. I use underscore because it's a good practice to each time that you're working with a private variable, to use the underscore to differentiate between the public ones. So for example, public name. You don't need to go back to your documentation. If you it's a good practice. If I see an underscore, this is a private one. If I don't see an underscore, this is a public one. It's a nice convention, a nice practice. So string, okay, and private credits number. Perfect. And then I will create my constructor, and my constructor, this is where I define the name of the student, string, and credits is the number, perfect. And then the same, this name equal name, and this credits equal credits, perfect. Let's go back to the classroom to see if it's working. And perfect. Now, TypeScript is intelligent enough to know that it is a class. Perfect. So we're working in object-oriented programming. And we're compiling back, by the way, to JavaScript. We're going to see these ones in a couple of minutes, how they work. And now we have finished the constructor. We're going to add getters and method setups. So this one, I want to get the name of the student. Get name, and I need to put the return time. It's a string, and return this name. Perfect. If I try to pass another kind of data, for example, if I try to pass credits, the compiler will throw an error because I cannot assign a type number to the type string. So even if I change the variable by mistake, just because this one is type number and this is type string, TypeScript will detect the error. So this has helped us a lot just to catch this kind of silly mistakes. And this is the kind of silly mistakes that can take hours to find out where the problem was. So we have the getter for the name. We want to get a getter for the credits as well. The credits. Same thing. It will be a return type number, and return these credits. Perfect.
Sorry, is the get keyword, is that just like standard syntax for JavaScript, or is it a TypeScript syntax?
Is the syntax of the JavaScript class. Even if the classes are the JavaScript classes are bad because they don't have inheritance, you can think of forget about abstraction and so on and so forth. At least they created this keyword, and this is the official way to get a a getter method in JavaScript and those in TypeScript as well. Okay. So yeah, this is the official way.
Cool. Thank you.
Yeah, no problem. And then we're gonna create a setter, set credit, and I will say amount, type number, and this credit plus equal, because we want to add the current number and add it to the amount. So we are going to combine those values. We're going to combine whatever we have right now to the new amount, and there you go. And we don't have a setter method on purpose for name because we don't want to override the name. Once we create a student name, we don't want to change that one.
I'm sorry.
Yeah.
Are there any access modifiers for the methods? Are they allowed?
Yeah, this is what these are the access modifiers. This is a private one.
Okay, but
for the methods, yes, you can create a private method. There you go. Yes, you can.
Okay, cool. Nice. Yeah. Cheers.
And you can make it public as well. Don't worry. Yeah.
All right.
Yeah.
So the default would be what exactly? The default would be like limited to the package.
If you actually put a function something, I'm trying to do that one. TypeScript will throw an error because you cannot use functions inside TypeScript. You need to use methods, and the methods needs to be defined by default if they want to be private or public.
Okay, so for example, we have set credit, for example, this method. Is that public by default, or is it?
Yeah, the getters and the get and the set methods are public by default. Yes.
Okay. Because so it's different.
Remember that a get and a set are supposed to. The only job for a get, the only job of a get method is to return a private property. So people cannot. Okay. So elements outside the class cannot modify your private one.
Okay.
And the only job of a setter method is to allow people to modify your credit, and this is important. Allow to modify your private properties, but only under your own terms. So in this case, okay, let me say what I mean by my own terms is that in another class, I will create a super dirty right now. I know that this is not a syntax, but in class 2, if I try to modify this one directly without passing for the setter, I can say something crazy like credit student.credit equal -1000. Right now, that will be, if this one were public, this will be allowed to do that. But actually, we can start making we can make some kind of security and say, if amount is greater than 0, so we don't allow people to actually start making subtraction. Let's write that one. If the amount is greater than 0, there you go. Then this creates equal. So we just added a layer of security. So in case that some student actually want to hack the system, we're not allowed to modify the credits for mess it up the credits for another student and actually put it in a negative value. So yeah, this is what is important to get the setter method instead of making it public, because with the setter, other classes can modify your private data, but only under your own terms. This is the rules that I just have defined a rule that if you want to modify the credits, you cannot use negative numbers because we don't want negative credits for the students. A student can have 0 credits, but you cannot subtract credits once they were assigned. So we just create a little bit of security thanks to object-oriented programming. So, cool. Well, thank you for the question. Thanks. Because this line of code is actually quite nice to have in place.
Yeah.
So perfect. We have our student class and our classroom class. We want to actually have the same one with the getter, and we want to get the name. The name, the string. And we want to return this name. Perfect. And again, get students. We want to return the student array. Remember, this is an array of students. And return these students. Perfect. I don't want to modify the amount of students once we create the classroom. I don't want to change the number of the course once we start the course. These classes are already in place. And let's create a third class, sorry, not class, a third file just to run this example. So I will call this one example school.ts. I will not call this one school on purpose, because if I call it school, you will imply that I will create a class. I don't want to create a class right now, so I actually will call it example 2. And example 2 will have a list of students. So for example, all my students is a type of student, and I will leave it as an array of students right now. That's it. Perfect. Oh, it's telling me that I need to initialize it because it's a constant. Perfect. Now I can start creating an empty one. I want to fill this one with random data. So before this class started, I just created a small super mega hyper dirty function for this one. So I will literally populate my data, my student list with a bunch of junk data. Just for an example. I can create a function here instead of a method because I am not creating classes. I'm just creating a quick dirty TypeScript file. So I will create, actually I don't even need a function. I can just go directly with a equal 0 with a for loop equal 50 e++. This is a quick and dirty. So const random name equal, oh, okay, random. By the way, this literally is creating not random. I will get a random number. We will convert it to a string, so it will become characters, and then I will pick just a couple of characters from this random string, and then a random constant random crates. Random. Oh no, I will make that the crates select 0. So crates equals 0. Perfect. And now I will do the super dirty thing that is all my students index to push a new student. Oh no, let me just create this one as a variable so it's a little bit organized. So student equal a new student. See, I just want to make it a little bit organized. And again, TypeScript is helping me. I need to pass a name and I need to pass a credit. So I will pass the random name that I just created. And I don't need this variable because if it is defined at 0, I just can put it like this. So each time a student enters enters this in this school, it will start at 0 credits. Of course, makes sense. So in my for loop, I will just push this student. Let me see what is the problem. Oh, I don't need to pass the index. I just can do that one. I think I need to. Do this. Literally this. No, sorry. This. Let me see what is the mistake. Property all my student doesn't exist in the type global of this. Let me see what was the mistake. All my students. Student. Oh, okay. I need to initialize as an array, even if it's empty. New array. Perfect. And this is a new array of students. Now it's working. So even if it's empty, I need to initialize the array, and then I can start populating the array. So let's see how it works. I will create a new classroom, for example, called web module, web course equal a new course. No web course. I cannot find it. I cannot find the name course, so I need to do an import here. I need to import the class. When we were working between classes, the TypeScript wasn't intelligent enough to know where the class was located. Because we are working in a normal non-class file, I need to do the import. Import classroom from classroom, perfect. And it's throwing an error. Okay, it's not.
Sorry, would you say that again? If we're working in a class file, in other words, its name starts with a capital letter, then TypeScript will automatically look between your files to find the gate. Okay, cool.
Yeah. You can see that this one is an array of students, and the student is in the same level. So yeah, in this case,
without importing,
was intelligence enough. Yeah, but well, to fix this error, 1 second, let me delete the first example. To fix this error here, I need to export the module. This is easy. It's just literally add the word export default here. So I can export the module, and the same with the student. Export default class. Perfect, perfect. And now it's working. Perfect. Now I will import student from /student. Perfect, and it's not making a mistake. Now let me see. Now web course equal a new classroom.
Yeah.
And yeah, that was probably the mistake, by the way. But this I needed to import it anyways. I'm pretty sure about that. Yeah, you need to import it anyways. So new classroom, and this is making an error because it's affecting two arguments. And the first one was the name was not provided. So let's add a name, and this is a short name for the variable, but here I will actually be able to make a more detailed name. So I will say web development part 1 front end. What a long name. And now it's complaining that it needs to have a list of students. So let me put the list of students. Yes, all my students actually, all my students. Perfect. And I will do the classical console log, of course, just to be sure that console log running the school. Just to quick dirty example. Now, how do we see this console? Well, we're gonna use node. So we'll go to the terminal. These errors are. Let me see if these errors are new or no. Okay, student. Okay, cannot find the name student. Now I need to do the import right now. Import student from student. Perfect. This one is fixed. So yeah, I needed to actually add imports as well here. And now we working correctly, 0 errors. Now I can open a new terminal window, and I will say no. Remember, you cannot run the TypeScript files. That's the reason we are compiling back to JavaScript, because remember, Node doesn't understand TypeScript. Actually, nobody understands TypeScript. You need to convert the code back to normal JavaScript, and that's what Node understands. So I will say node dot slash, and I will run example2, example2.js. And I see module not found. Let me see this one. Import classroom. Okay, I think that let me see if this one was a mistake, because in my previous example I was running like this. No, let me go back just to my.
I think you're one directory up too high. You're in TS Live. I think you need to drop down to JS.
Okay, let me see.
TS5/JS/example2.
Yeah, let me see. No, I think I need to enter actually. Let me see, because we are on the root right now, so it will be node.
But the file we're trying to run is in the JS folder, not in the root.
Yeah,
if I'm understanding correctly.
Yeah. Okay. Maybe that was a mistake. Let me see if this one actually. Yes. Oh yes. Cool. You're right. Thank you.
Pleasure.
So you can see I'm literally calling my classroom class. It has the name web development, and it has the student list, and the student list at the same time actually have these random names I just created, and this one has a random bunch of elements. If I want to call, for example, only the first student, let me get a particular student, console log, web course dot, and I can access my, I'm not accessing my, I access my properties, but thanks to the getters. So let me see if I delete the getters. So just to confirm that, I will delete the getter students, And I will delete this one. I will say console log again, console log web course dot name. So I cannot access anymore my student list because I delete the getter. So this is important. This is super nice. I will get it back. And I will say again, students, and because we know that students is an array, I can just pass, for example, the number 5, and I can run this node code again. Let me just clear the terminal with Command K to clear the terminal, and I will run this command again. So I will only get the student name Kur 35 and has 35 0 credits. So yeah, this is a super dirty, quick example of the student list. We are about 15 minutes, so I want just to, instead of coding something, I just want to show the other example, the super stuff, cool stuff that you can actually make with the TypeScript. Let me open this particular project, the one that was a little bit more complete. TypeScript. So for example, we can create interfaces. So for example, for the SDA, let me open the SDA folder, SDA login. This is something that we actually built using TypeScript in the prototype. You enter the software module, you have these nice links, and these links you can see that they behave differently. They can be positioned inside the document section, in the slide section. They can change the icon, and depending on the section they belong, they can change the color. You never saw a green icon inside this video section because all our videos will be painted red, and the only thing that we can change is the icon. So this is so it's easier to understand. We actually wrote a little bit of nice documentation about the SDA here. Development, material list documentation. Let me show you. So by the way, this is how you make a README file, to be honest. There you go. So you have the type. You can have your material links. You have a name property that is a type string. You have an icon that is also a type string. You don't need to define the color, because remember the colors are defined automatically. Because I know that I'm working with a bunch of non-developers, and if I allow them to choose colors, shit, the platform will become like yeah, it will become like a clown. It will be colors everywhere. But you can see that documents are always blue because I want to use the analogy of Microsoft Word. The slides are always orange because I wanted to use the analogy of the PowerPoint slides. The videos are red because the most popular video site or video platform on the planet is YouTube, that is red. The workshops are purple, to be honest, because Dina in the last minute wanted some workshops, so I needed to create a new color, so I just throw the purple. The coding are yellow because in our platform right now the only language that you can code is JavaScript. We don't code in Java here. We don't have Python, so at least in this iteration number 8, it makes sense that the coding is yellow because yellow is the official color of the JavaScript. And then the evaluation was green because you're supposed to, if you pass green, it's a traffic light. If you go green, means that you can go to the next model. So that was the thinking behind this. So you can create, if you want to create a link, this will not work right now because the example is not complete. But imagine that you wanted to create a link and somebody was lazy or make a mistake. Having an interface, and let's add all the elements. Name, icon, as I mentioned, is a string. Link is a string, you know. The order is a position. So for example, I want to say that this icon, for example, this is the module introduction. I can create it 3 days later before some exercises, but I want to make it appear first. So I can tell if you have a position number 1, it will become first, and so on and so forth. And the categories are the ones that we define here. So imagine that somebody made a mistake and doesn't, 3 weeks later, they forget this. Is this coding or is code? And this can make mistakes. So we have something called enums, enumerators. So for example, I can say e category, and these are the categories that I have in the documentation. So by having an enum, I can create something super cool. For example, let me say Java core, GS course. This will not be real TypeScript code that is working, Like I can say that inherits from the immaterial link, and it will, sorry, it will material link, and it will say equal. It will be an array, and it will start making throwing errors because I haven't passed a name, so I need to pass a name. So for example, JS snippets or to-do list. Then they will still throw me errors because I don't have an icon, and the icon can be also an enumerator, by the way. That would be super awesome. So they can, but for now, I would say that the icon is anything, and if you write some mistake, it will default to a random icon. So I would say just file alt. So it's a piece of paper, and in our documentation, we actually have a nice list of. These are all the icons that you can see in the platform because we actually have it as a string list, but it can become an enumerator to be even more secure. File alt is this one, the document icon. And then the link is, for example, github.com/blah/git. And the order, I want this one to appear first, so we'll put it as 0. Remember, we are talking about arrays, so this is a 0-based array. And this is the cool part of TypeScript. Right now, it's not working because the example is not complete, but I can say category, category dot, and there you go, it's working actually. And you can see the list of the ones that we have in the documentation. So you don't need to remember, oh, what it was coding or code, because you can see the real name. And look it up. In the end, it's not even coding, it's called coding exercise. So even I was making a mistake in the documentation, but TypeScript to the rescue by having an enum, I can use the correct one. And I definitely should make the same one with the enumerator, for example. Let's create one super quick. eicon.ts, and it's an interface, no, enumerator, sorry, enum, eicon. The E is a standard practice because if I put icon, I would think that this is a class. It's a class icon, no, but we don't have class icon. We only pass a string, and then CSS with font awesome will take care of adding the icon in the web page. So I use an E icon, so I know that this is an enumerator, and I can create my list of icons. So for example, document, slide, and so on and so forth. But you notice something, because we yesterday made the CV, we know that we don't pass document to font awesome. Font awesome doesn't know what is a document. It knows this string, so you can actually say document equal file alt, and slide equal layer group, and so on and so forth. So if I change this one icon to this one, to E icon, perfect. Now I can do this one, and I can say E icon dot, hey, there you go. So I don't need to remember anymore whatever the names, this name from Font Awesome, because for example, this one is easy, the play icon. Users for the workshop is easy, but for example, this one is tricky. This one is code, and you maybe think that a couple of months later you think, oh, I want to use the code laptop, and you write this one, and it doesn't work because in Font Awesome the correct name was laptop exercise, and I can just change this one to laptop, and then I don't need to remember what is the correct name. I just need to remember that the shape was a laptop, and I can add that particular E category. So something like so E icon. I can say the icon, the laptop icon is called laptop code, and so on and so forth. I save it here, and now I probably have the laptop, and this one will be an icon, and there you go. This will be actually the stuff that the TypeScript will put for you. And congratulations, you have a new element. I need to put a constant. This exercise is not complete. That's the reason that it's not working. This one is 3 numbers missing the perfect properties, immaterial link, blah, blah, blah. So well, this one is incomplete, but even if the exercise is incomplete, you can start seeing the advantage of manipulating data with TypeScript. And this is gold when you start working with JSON, because in JSON, you will have strings, you will pass a lot of data, and you need to know which data type it is. In JavaScript, everything will be treated as a string, and you know that you need more information than that. So having TypeScript with interfaces and enumerators will be extremely useful. So we are 7 minutes left. There is another advantage, like for example, you can have generics. You know what are generics, so you can create a special array type, and you don't need to define, for example, a type of student. You can inherit from, for example, master's students, bachelor's students. You can pass a generic or have inheritance. You can do basically anything that you can do in Java, you can do it in TypeScript. The syntax is not the same, but the functionality, the features that you have in Java are the same in TypeScript. Something that the JavaScript pure classes doesn't have. They have getters and setters, and that's it. You don't have inheritance, you don't have abstraction, you don't have interfaces, you don't have enumerators. To the point, that's why they are basically useless. But TypeScript classes are actually as powerful as Java. So anything that you can build in Java, you can build in TypeScript. It's not the same syntaxes, but all the concepts that you learn in programming foundations, you can use it in TypeScript. To the point that with Kevena, the model responsible from programming foundations and help in programming that, we were talking about even in the second iteration of the SDA. What if instead of teaching JavaScript, we teach TypeScript, because the transition for the students will be much more smoother, because they will utilize all the concepts from programming foundations into TypeScript. We actually want to do that. The reason that we haven't done it is for two reasons. Number one, some TAs are afraid that they need to be trained into TypeScript first beforehand, because Cotejo, they don't teach TypeScript inside Cotejo. Don't ask me why. So we need to train the TAs, something that for me is a nice investment, because I really think that in a weekend workshop, training teaching assistant that they have 5 years experience in coding, it will be so much easier to train them in a weekend on how to use TypeScript, that helping rookie to allow the teaching assistant to help students in the transition from Java to TypeScript instead of the transition from TypeScript to Java from JavaScript. That I think that for many of you, the transition from Java, the ones that they have JavaScript experience was easy because then you know the language. But the problem was changing from Java in programming foundations to JavaScript in the second week of programming in depth, was that all the concepts we were explaining during 2 weeks of abstraction interfaces, they were totally useless in JavaScript. So we're seriously thinking about moving the entire web development module and programming in depth into TypeScript. I hope that for the next iteration, or at least the 10th one, I feel that will be a major failure if we don't do the transition in less than 1 year. Let's hope that we can do that. At least in the 7th iteration, we never mentioned TypeScript at all. So there is a couple of students in the SDA 7 that they want to apply for a job in web development. They're probably gonna ask the same question that Steve asked in the morning. What is SAS? And they want to find something similar with TypeScript. What is TypeScript? We never even learned about that there is a library called TypeScript that works what it does. So at least that's the reason that I create this optional course, this lecture. So at least, even if we cannot change the entire course to TypeScript, at least I give you the basics, so you know what is important, and you can keep learning on your own. With all my talk out, we can have a couple of questions now.
May I?
Yeah, go ahead.
I have two actually. So first question would be, okay, so we have TypeScript and we have Java. Mm-hmm. And I think, like, correct me if I'm wrong, but Java applies to like a different type of programming. So I think Java is more of a backend stuff, and with all this frameworks like Spring and so on, it just makes it easier to maintain the backend, right? And maybe, I don't know if TypeScript is being supported with this kind of frameworks as Java is. So for example, we have Spring, which makes the backend operations a bit easier and makes the connection between the website and the database quite smooth. And do we have this type of like developed frameworks for TypeScript? So can we really replace them?
Yeah,
Java
okay,
with,
that's a
with
nice question.
TypeScript?
I will need to break it down into a couple of more, make it a little bit more visual, so I will share the screen more. And let me create
All
a
right.
quick PowerPoint slide again. This one will be quite ugly, but it's only for demonstration purposes. So I will create a shape here. I know that the colors of Java are blue and red, but I will use just red to make it easier. Okay, this will be Java. This will be JavaScript. And yellow, remember, yellow is the color of JavaScript. And this one on the end is TypeScript. So let's say this is Java. I will paint it white. Oh, yeah, I will use this one. This is easy to see. Java. We have JavaScript, and JS. This is TypeScript. Okay, TypeScript. To create a backend in Java, you can create it by hand. And I am not joking. You can create it by hand. When you wrote a file into your hard drive using the file string, blah blah blah, and so forth. Imagine that your computer is a server, and congratulations, you just store information in a server. So you don't need a Spring to create a backend in Java. You can do it by hand.
Yes.
You use a Spring.
Exactly. Yeah.
Is because it's so much easier. You don't need to write a lot of code that people can use. So, for example, in Spring in Java, you have a Spring for making.
Yeah, I mean, like, back in the older days, we had to really delve into all this, like MySQL expressions or expressions, and communicate it. Like using the J2EE. That was a disaster, and Springs just makes it all easier, I guess.
Yeah, so we have libraries. This is a library, a Spring for that one. I will create a library for this one and this one. And for JavaScript, we have something called Node for backend easy. So you can make the same stuff that you do in Java, you can make it in JavaScript using Node. This is what Node is for. This is the reason that we installed Node. And now let's add another library. This is going to be a little bit confusing, but let's go with the flow. TypeScript for coding using object-oriented programming. So JavaScript has this library called TypeScript, and now if you ask, can I build backends using TypeScript? The answer is of course. Remember that Node is not a library from Java from TypeScript. What is happening is that I will put an arrow like this one. I will actually change in the other direction. And what I'm trying to imply is that TypeScript compiles to JavaScript. So you can use TypeScript to use a nice code base, and it will become pure JavaScript, and it will then run in Node. So that's actually literally what we're doing right now here. Sorry, this one, not this one here. TypeScript. If I do the other hand, let me show you what happens if I put the TypeScript folder / example 1.ts. Remember, we have the JavaScript file as example 1.ts and this one 2.ts. Let me see what happens. I press enter. Unexpected token is a string. Like in this moment, JavaScript is having a mindfuck, literally, because JavaScript is so stupid that doesn't know that what is a strong typing. So look, breaking in this particular point, as soon as you put the two points to define the data type, JavaScript just broke totally.
Yeah.
So if you want to do that one, you can write a TypeScript, convert it to JavaScript, just like we learned today, and then Node will become that one. But I don't want to get outside of the world. Imagine that you don't want to even compile to Java. Imagine that you can actually build an entire TypeScript, the entire backend in TypeScript, and you don't need even to compile at all. Make sense? Yes or no? Maybe not. I will explain a little bit later. But there you go. This is Dino is by the creator of, is for the same creator of Node. And he said, you know what? Node is so old. I have learned a lot. I made a lot of mistakes when I built Node, and I built Node by hand using JavaScript. Imagine building an entire backend without strong typing. Imagine how hard that was. So he says, you know what? Fuck it. I want to make a new node using TypeScript. He actually invented Dino. And we're gonna go into detail in this one in an optional talk called Future Technologies, because I strongly believe that into 3 to 5 years, Dino can be as popular as Node. Maybe yes, maybe no, I don't know. This is a gamble. That's the reason I will put it in Future Technologies, because I cannot teach Dino and people spend weeks learning something that I am not sure it will become popular or not. That's the reason I put it in a special optional talk called Future Technologies, to see if we can predict the future and make Dino, and if I can get the bet right that Dino will become popular. Maybe not, maybe, I don't know. But
right. So yeah, SDA 13 is going to be super lucky.
Library.
Definitely.
Dino. And you can even forget about this arrow and stay in TypeScript, and you don't need to compile. You can literally upload to the, you will be able to make that and say, right, upload this folder. Don't compile. I don't care about that. Run pure TypeScript. With Dino, you can do that.
Okay, and so why would anyone choose Java over TypeScript, for example? Why would anyone
Java
do
or JavaScript? Java or JavaScript?
Java. I mean, like, you know, if you can create a backend using a simple tool, which would be JavaScript or TypeScript, why would I bother with Java?
Yeah. Pros and cons. Pros of Java is faster. It's faster than TypeScript. So JavaScript. Sorry. So if we go like this, something like real quick. I don't want to open PowerPoint again. I don't want to say that this is the official list and I'm making mistakes, but on top is slower and lower is faster. Mm-hmm. JavaScript is here. Here in the middle is Java, C#, Swift for iOS. Right around here in the middle is Python. A little bit lower is C, is C#. C++. A little bit lower is C pure, and right on the bottom is assembly. So the lower in the pyramid, in the line is faster. So Java is faster. If you want to do something super complex, I don't know, as a bank, Java. Actually, the backends in banks are done in Java. If you want to do even something more hardcore than a bank, you know what is faster? That is more hectic than a bank. It's actually the stock market. The stock market is probably run on C# and C or C++. And something like crazy as that. So why do you want to use Java? Because it's faster. Why do you want to use JavaScript instead? I can give you a pro. Because if you want to build code the front end and the back end, you can use a single language. You cannot use Java to create a front end, period, on the web. But you can use JavaScript. Although it's slow, you can use it for the front end and the back end. So you can imagine that you're a small startup, 4 employees, and your 4 employees are proficient in JavaScript. 1 month you need to build the backend, so you can tell the 4 developers go build the backend, and then the next month you can go build the front end, and you can start splitting your team. If you have a small startup and you have 2 Java developers and then 2 JavaScript developers, and the teams doesn't know the other language. If you need to, you have a deadline in the back end, you cannot put your JavaScript developers to work because they don't know Java at all. But imagine if you have the entire backend and the front end in a single language, you can shuffle your team and make work in a different part of the project on demand.
Yeah.
You know that the project will not run as fast as you make it in Java. But to be honest, many people don't care.
Yeah, that's what I'm afraid of.
Yeah,
like this is coming from me. I'm like Java fanboy, right? So it's coming from me. I'm afraid of my future, honestly.
Yeah. So imagine that you're a small startup. You want your first mission is not to build the fastest website. For example, Instagram when it became a hit, nobody said oh, I use Instagram instead of Facebook because it's faster. That is one thing about faster. It was easier to use. It was hip. It was cool. You can say 30 million reasons, but nobody said because it's faster. So when you're a small startup, speed is not your priority. It's just getting your million users. Once you have 1 million users, you can start saying, you know what, I care about performance. I will hire a dedicated team of Java developers or C developers, assembly developers. I don't care. When you're rich, you can do whatever the fuck you want. But when you're a small team, maybe performance is not the top priority. It's important, maybe it's not the top priority.
I have Oscar, a quick question. In terms of like external libraries, like JavaScript obviously has tons of libraries. If we now npm install some library to use that obviously comes with its own functions, TypeScript is not necessarily going to have. How do we sort of handle that situation if TypeScript is not aware of the typing in the parameters of, say, a function that you're getting from a new library?
Yeah, if the library doesn't have awareness of TypeScript, you will not get the data typing for the particular the APIs of the library. Unfortunately, that's the truth. But many popular libraries are I cannot say that they're migrating to TypeScript, but at least they're creating an abstraction layer. So when you actually do npm install, you will get the data typing.
Oh, okay.
And you can do that in your own libraries. There is something that is called. I will write it in the chat. It's called DTS extensions. Lowercase DTS extensions. I will totally out of time, so I cannot go into details. But this is a file that you can create. It's basically similar to an interface. Here you can tell you can make that your JavaScript files. You tell them at least that the name is a string, is a similar to an interface. So you get some basic information about that kind of stuff. But it's not the same as rewriting your entire library in TypeScript. That would be the best scenario. This is a workaround, so at least you have some knowledge of that kind of stuff. And many libraries already have that. And if a library doesn't have that, it's a warning sign that it's probably this library is not that good, because Moment.js already have this information. React already have that. So all major libraries are already having that, because every backend developer or senior developer, everybody loves TypeScript, to be honest.
Okay.
Yeah.
So yeah.
Don't blame them, really.
Yeah. Data safety.
Cool, thank you.
So yeah, any more questions? If not, I think that we are all for today. I will put the contents of this. I will upload the lecture, of course, and I will pass a zip file right now with the exercises. Yeah, that will be it.
All right.
Thank you very much.
Thank you very much, Victor. That was super helpful. Cheers.
No worries. Thank you. Then see ya. Bye.